We are Team 7203, KNO3, representing Plant High School in Tampa, Florida. Post-kickoff, we began the season by brainstorming ideas. Initially, each member sketched their own design and shared it with the team. We held group discussions on the pros and cons of each design and agreed on one design. We divided into groups of two, with each group responsible to prototype one aspect of the robot. Each separate design was then integrated to build our robot, Titan, and to maximize scoring. We used Dropbox to store all of our work, which then can be accessed by the entire team.
After beginning work on our chassis, we realized we needed more open space, so we created an aluminum plate mounted on the bottom of our robot that would supply maximum support, allow more height to be devoted to the slide systems, and eliminate the ability for balls to roll under the bot. We chose an 80-20 slide system with ball bearings and fishing line to lift the slides. We used a 1x2 inch double slide bars that allowed for more side-by-side stacking and also gave us some additional lift height.
Our original idea for the collection mechanism was to use zip ties around a pipe, but they became bent and unreliable. Our final design uses spearfishing tubes fed through a PVC pipe because it is both sturdy enough to collect the balls yet pliable enough to not damage the playing field nor our robot. The hopper is made of Lexan polycarbonate bent into a half-rectangular prism mounted on the slides at a slight slope. A polycarbonate cover and shields near the collector guide the balls into the hopper. A series of wood blocks keep the balls orderly and prevent jamming, much like a pinball machine. Forward and backward servos keep the balls within the box until we need to deposit them or collect more.
The ramp was our final design element. It was modified to fit between the collection unit and the hopper. The ramp is made of an aluminum sheet with a curved slope to seamlessly transition the collected balls to the height of the hopper entry point.
After we began practicing, we discovered that we were at a risk of sweeping balls into the internal sections of our robot when our slide was up, so we added a limit switch on the bottom of our robot. When the lift is up, the switch is activated, which will close the front servo door as well as turn off the collector. For the autonomous phase, our robot is capable of hooking onto a tube and pulling it over to the parking zone and scoring in the tube.
In efforts to spread awareness of the FIRST program and excite freshman students to join, KNO3 sent flyers to both Madison and Coleman middle schools. We visited Coleman's technology classes to demonstrate our robot and talk about FIRST. KNO3 spent time with the engineering community touring Vitality's research and development facilities. At the request of one of our sponsors, Nestle Professional Beverage, we hosted a booth at the Metropolitan Ministries Partnership School Fair Day. Team members talked about their experiences and encouraged students to pursue interests in STEM. Our goal this year was to raise enough funds to cover all expenses of the team. We partnered with SAMS to demonstrate our robots and talk about FIRST programs with their patrons. KNO3 also applied for grants and contacted various businesses in the community to secure funding. We are happy to report that this year we are in the black, having raised over $2,700.